Hi everyone, welcome back. Today we are solving special binary string. So the problem tells us that a special binary string means that it has the two following properties. One is the number of zeros is equal to the number of ones, and two is every prefix of the binary string has at least as many ones as zeros. And this just means that every prefix has either more ones than zeros or the same number of ones as zeros. And we are also told that our given input string is a special binary string on its own. And we can make moves by choosing two consecutive non-empty special substrings of S, and we can swap them. And the reason we want to swap is because we want to return the lexicographically largest resulting string possible after applying the operations on the string. So if you look at this example, the largest possible would be this, because we will swap this binary substring with this binary substring since it is lexicographically larger, since 1 is larger than 0. So this will be our result. And for this example, this is a special string on its own, and there's no order to switch it with over here, because if you put a 0 before 1, it will break this rule. So this is our only option for special binary strings. So we return this as our result. So now that we have seen some examples, let's get to how we can solve this problem. So for this problem, we are told that the input itself is a special binary string, which means that each prefix needs to have either more ones than zeros or same number of ones as zeros. So because of that, we will know that all special binary strings inside of this input will start with 1 and end with 0. As you can see, this starts with 1, ends with 0, starts with 1, ends with 0, starts with 1, ends with 0, starts with 1, ends with 0. And now that we know that, we can actually approach this problem as a height. So a 1 in the string will increase the height by 1, and 0 will decrease it by 1. And we want to look for the spot where the height is 0 relatively. So the height is 0 here. So this is a binary string. This is a binary substring. Height is 0 here. If we start here, so this would be a binary substring, and if we start here, once we end here, this will be a binary substring. So now that we know that, we can kind of use recursion to solve this problem. So first we will set up a substring array to an empty array, and now we will look for the end spots where the height is 0. So it will be like here, 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 and here. And once we see one, we will append 1 in the front and 0 in the end, because that's the pattern for all binary substrings. And we will call it recursively for the string of everything in between the 1 and the zeros, and we will add that to substrings. So we will start at the longest one and then add everything in between, and then in between here, and on the way out back down to the longest string, we would sort the substrings, and it will be in reverse order because we want ones to come before zeros, since 1 is lexicographically larger than zeros. And finally, we would combine the substrings and return that as our result. So let's go over this example real quick. So first we would iterate through, and we would add height by 1 if it's a 1. If it's a 0, we will subtract 1 from height. Now the first 0 that we see will be over here, so we will add 1 0 to the array and recursively call everything in between. So we cannot add this just yet, so make the recursive call. Now the first special string, nothing in between, so we can add it to substrings. And now we come to the next one, make a recursive call. So now we will come to here, nothing inside, so we can add it to substring already. And now we will come on the way out. So now that we are here, we see that we have 10 from this and 1100 from this. And remember, we need to sort them, so let's go ahead and do that. And now that we have sorted it, let's come to the final layer, the most outward layer. So it will be 1 plus this and 0. So it will look like this, and then finally we can return this as our result. So the time complexity would be O of n squared, where n is the length of the input string, because we'll have to iterate through to get all the height, but in between there can also be special strings in between, so we will have to calculate height and add to substrings n squared times, so time will be n squared, and the space complexity would be O of n, because this will take up to n space at the very most. So now let's get to the coding part. So first we will initialize substrings to an empty array. Now we will declare start as the start of an index for the substrings we will add, and height will be initialized to 0. So now we will look through the string S. If the value is 1, increase height by 1. If the value is 0, then we will decrease it by 1. And now if height is equal to 0, then we will add to the substring. So it will be append, we will use an f string 1, and in between will be the recursive call, so self.make larger special, and it will be s of the start index plus 1 and all the way to the current index we're on, and we will add 0 at the end. And now reset the start index to index plus 1, and finally we would sort the substrings after all and make sure it's reversed, and then we can return empty string join substrings to combine everything. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.